Okay, so I wanted to answer some of the more challenging questions from Corbett Maths involving the quadratic formula. So these come from the Quadratic Formula worksheet from Corbett Maths, and it's included in the packet, but you can search it up on Corbett Maths if you do not have it. So looking at question 5G, if you had something that looked like this, remember to solve the quadratic formula, you need to have this format, this setup, in order to know what the values of A, B, and C truly are. So that means that I need to take this equation and somehow set it equal to 0. The key is having it set equal to 0. Don't worry so much about the x squared, the x, and the c. Just make sure that you move everything to one side of the equation and you have 0 over here, and then that will all sort itself out. So let me see, grab a different pen. Okay. I always look at the x squared terms first because that's our highest index, our highest power. I like to keep x squared positive, if possible, the term in front of it, so the number in front of it positive if possible. Honestly, it just makes things more simple, and there's not really a reason for it, but I just think in the long run it helps things a lot if you keep it positive. So that means that I want to add 2x squared to both sides of the equation. Right, keep in mind we have to keep the like terms together, so the x squareds will stay together, the x's will stay together, and then the values on the end, the constants or the integers, whatever you want to call them, those must stay together. So I'll bring everything else down. This has gone away. I'll bring down this bit, x minus 1 equals, this becomes 2, take away 1 is 1x squared, or just x squared, and then bring all of this down, minus 5x plus 8. I want to also move all of this to the other side as well. So I'm going to take away x first. Remember, x's go with x's. So I'm left with minus 1 equals x squared. This becomes minus 6x plus 8. And then the last thing I need to do is add 1 to both sides. This becomes 0 equals x squared minus 6x plus 9. Actually, you could factorize that. Let's just go ahead and solve by factorizing, just because I think if you needed to, you would know that the a value, b value, and c value now are 1, minus 6, and 9. But what I want you to realize is that these equations you can solve by using any method that we're learning about. So we've learned about factorizing so far. We've also learned about the quadratic formula, and we'll continue to learn new methods. There's at least one more that we're going to discuss, but you can use any of these methods and you should come up with the same answer. So maybe I'll just show you both actually. Let's see, so if I factorize this, you would end up with 0 equals, double brackets, the two factors of 9 that add up to a minus 6 are minus 3 and minus 3. So my answer is going to just be 3. So I already know my answer, but I'm going to double check quickly by using the quadratic formula. So I have x equals negative b would be a positive 6 plus or minus the square root of b squared, so minus 6 squared minus 4 times a is 1 times c is 9 all over 2 times a, which is 1. I can already see that this would be 36 take away 36, so that all becomes 0. It all actually just goes away. So I know I'm moving pretty quickly, but if you work that out, 36 minus 36 is 0, that's gone. So now we don't even have to worry about the plus or minus, because really what you have is 6 plus or minus 0 over 2. That just becomes 6 over 2, which is 3. You only have one answer. So that's how it works out if you only have one solution. It matches. And that means that this parabola, or this graph, actually looks something like this. I'm not sure exactly what it would look like. I think it would probably look something like this. Actually, yeah. The y-intercept is actually this value. We'll learn more about that later, but it would look something like that. Oops, sorry. What am I doing? The y-intercept is 9. Well, it'll look something like this. It crosses the y-intercept, wow, I just messed up everywhere. It crosses the x-axis once, and then we'll learn later on that that's the y-intercept. But anyway, the solution is at x equals 3. Sorry, I should probably just cut all of that out. Anyway, the solution is at x equals 3. I probably won't cut it out. I'm just going to leave it in. Whatever. Okay, there are a few more complex questions that I want to go over. So I'm just going to kind of simplify them for you and set them up in this format. And then I'll let you use the quadratic formula from there so that you can solve them on your own. The toughest part is just getting from this into this format. That's the toughest part, so I'll help you with that. In this equation, or really in each of these, we can use cross multiplication. So anytime you have two fractions, I'll give you an example. If you have a fraction that looks like this set equal to a fraction that looks like this, you can just use cross multiplication and write a new equation where A is multiplied to D, and then that's equal to B multiplied to C. Okay, so I'm going to use that property or that idea to solve or to rearrange this equation. Whenever you have expressions like this, you have to group them together in brackets. They must be grouped together. You cannot split that x minus 4 apart, and you cannot split that x minus 2 apart. I would just always go ahead and put them in brackets anyway, just so you know that you cannot split them apart. So if I come over here, I'm going to rewrite this as 3 over brackets x minus 4, which is equal to, I'm going to change the right side into a fraction over the value of 1. So now that I have this fraction set up, what I'm going to do is use cross multiplication. The reason I put this over 1 is because there's nothing there. I wanted to put it into a fraction form so that I can use cross multiplication in order to get my setup going. So here, I'm going to multiply the top across with the bottom of the opposite fraction. 3 times 1 is 3. Set that equal to the opposite values multiplied together. So we have x minus 4 brackets, x minus 2 brackets. We need to expand the double brackets. So I still have 3 equals. This becomes x squared minus 2x minus 4x, last terms plus 8. So let's simplify, minus 6x plus 8. And then remember, I need to set it equal to 0 to truly find out what the a, b, and c values are. So I would take away 3, 0 equals x squared minus 6x plus 5. Actually, yeah, you could factorize that too, but solve however you like. If you want to use the quadratic formula, a is 1, b is minus 6, and c is 5. But you should be able to factorize with minus 1 and minus 5 to add up to minus 6. So honestly, if you want to factorize there, that's fine with me. And you would get your answers from there. Solve. So we're not done yet, but I just want you to realize that's how you set that up. Okay. I'll work with the next two as well to help you set them up, and then I'll let you solve from there. So question 6b, again, we have that format of a fraction set equal to a fraction. That's when you can use the multiplication, or the cross multiplication, sorry. So a fraction set equal to a fraction, I'll just cross multiply. Top opposite with the bottom, I times those together. Remember, I put everything in brackets and I keep everything in brackets. And then I set that equal to 4 times 3, which is 12. Whoops. 12. Okay, so expand the brackets on the left side. I have x squared plus 3x minus x is plus 2x. And then I have minus 3, and that's all set equal to 12. Remember, we need to be set equal to 0 in order to have this format, in order to solve. That's always the case. So I'm going to take away 12 from both sides, giving me x squared plus 2x minus 15, which is equal to 0. And I think you could factorize that again. Yeah, if you factorize that, that would be x plus 5, x minus 3, and set that equal to 0. So your two solutions are x equals minus 5 and positive 3. Again, remember, you can solve using any method. If it is on the quadratic formula page, obviously I would like for you to use the quadratic formula just to practice it, but I mean, in the future, I want you to use the quickest and easiest method. So quadratic formula is a little bit more time consuming, obviously, than what I've just done there with the factorization. So if you can use the factorization, just go ahead and do it. All right, last question here, question 6c. Let me move this somehow. Okay. So So question 6C, this one is a little bit different and honestly quite challenging, I think, for the level that we're at right now. And it might not be very easy for you to understand this right now, but I'm going to try my best to explain it to you at your level. Sorry, that sounded condescending, but it's just the way that it is. So let's see. We want to basically kind of find a common denominator here. And so what I'm going to do, imagine this has a denominator of 1, I guess. What I'm going to do is multiply, I guess, by the least common multiple. Yes, in order to basically get rid of all of those denominators that I have right there. So if I multiply every single piece of this equation, including the 0, because when you multiply something to an equation, you have to multiply every single term in order to keep that equation balanced, in order to keep it equivalent to what it started out as. You can't just multiply one value by this because that would kind of throw everything off. You have to keep it consistent. So every single term is multiplied by x squared. You must multiply every single term. Do not leave anyone out. Nobody. So if I multiplied 45 over x squared times x squared, these x squareds would cancel out. So you'd be left with just 45. Okay, I'm going to kind of move quickly through that piece because if you want to spend more time with that, you can. I'm not going to go too much into detail with that. That's for kind of a later chapter. But if you want to work out how that simplifies to 45, you can spend your own time on it, honestly. Let's see. So if I had 4 over x times x squared, that would become 4x. And then this one would just be x squared times 1, which is just x squared. And then if I multiply anything to 0, it just stays at 0. So look at that now. If I swap all of this around, I'll bring this out first. This comes second. And then plus 45. Now I'm in that format of a equals minus 1, b equals minus 4, and c equals 45. It actually turns out, though, that's if you wanted to use quadratic formula. But it looks like we can factorize again. Can we? Wait, no, I don't actually, wait, yes, hold on. Yeah, if I change this to minus, if I factorize out that minus, because we have this minus out in front, which I don't like, I'm going to factorize that out. X squared plus 4x minus 45 equals 0. You can always just do that. You can always just factorize out the negative value, and basically the sign of everything switches. And then you can think of it as, oh, I'm going to divide this entire equation by -1. If I divide by -1, the 0 just stays as 0. And then all of this just stays the same, and that negative is gone because we just divided everything, including the 0, by -1. And 0 divide anything is 0. That's the nice thing about working with these. You can kind of do whatever you want because that 0 allows us to just divide anything out if we need to. And now it should work. Yes, now we can factorize. So x, 9, and 5. And that would be our factorized version, and then our two solutions are here.